Welcome to Cujo Sound. This is Unity and Wwise integrations. Hello and welcome back to Cujo Sound. Here today we are going to check out some of the Wwise features that we have basically previously already done before in Unity, but now we're going to make it work in Wwise. And what we're going to do is that we are going to create an ambient area. Now, there are several ways of dealing with this specific issue. There are also certain calls in the code that you can use, which is different from just having a regular emitter. But we are going to do it the regular emitter way, and then we can move on and I'll show you some other tricks later. Here we have this giant room here that I've made. As you can see, it covers almost all of the level. And this here over here is the script that I've made. The point of it being that we add a listener and our controller and it calculates everything. And then the emitter, which is located here as a child of it, it's physically located here, will follow our player as we move around. And we'll get to that later. Now, I also have some of these ignore areas and some RTPC options here. I'll get to that in the next video because I want to show you how to do this area first, and then we get to these ignore areas. All right, let's get to it. So what we have is our script here, and we need to define our third-person controller and the actual audio listener. And as you might remember from the previous video, we moved our listener to be this one here, instead of being the actual third-person controller. So the audio listener is now this specific object here. Also, in the previous video, we discovered that if you do not, up here in Wwise settings, remove that it should automatically add a listener to the main camera, then it does so all the time, which is, of course, really annoying. But it's just a nice thing to know that why your listener keeps coming back on the main camera. But we want it to be on this game object that we have right here, as you can see over here. And it still runs our orientation as we added to it in the previous video. Okay, so I'm going to press play, and you're going to see this emitter here move around with the player. As you can see, we have highlighted the emitter, and as I move around in this area, it is moving with me. Now, if we really sprint far enough away here to the outside of this boundary, as you can see, the boundaries end here, and we are moving about. As a character, we are located here. Let's select both of these. And as you can see, the emitter moves. The emitter also has a sphere collider on it that turns on the sound when we're in it and off when we're outside of it. So right now there's no ambient sound because we're outside of the collider. Once we enter the collider over on the left, and as you can see, it follows me even if I'm outside of the collider. And when I enter the collider, the sound should start playing. So when I enter the sphere collider, the sound should fade in as I approach it, and as I enter the big box collider, the emitter will follow me. One of the things that are really difficult here is to make the box collider also work if the area is skewed. Right now, it only works if the rotation is 111 or 000. But let's take a look at the code and see how this works. If you watch one of my previous videos about how to do this in Unity, you can actually totally follow that video if you want to. It's the same approach. We just move another object as our audio emitter instead of moving the Wwise audio emitter. But what we need to establish all our physical needs. So we can make a nice comment here and say all our physical needs. By that, we make a comment so that next time you open this script, you will know that everything here is commented as all our physical needs. So that in that way, you can keep control of what's going on. It's a smart way. We need our usual public bool of enable debug. We might as well go ahead and create that to begin with because we know we're going to need it. We need to know where our emitter is. We need to know where our character is. We need to know where the listener is. And we need to know where the collider is and what our actual listener position is. So we're going to create a public game object, which we're going to be using as our audio emitter. And we need another public game object, which is going to be our character. And these will, of course, appear in Unity, and we can simply just save this as a prefab and then add these and save it in the prefab so you don't have to do it every time. You only need to do it once. And we need to know where the listener is. So we also need an AK audio listener. We're just going to call it listener. This means that we can add any object to this part over here. So when I save this, you'll see that they appear over here in Unity. So as you see, they already appear here. Our audio emitter we can add, which is the emitter that we're going to add to the script. And the character is our character like this. And our listener is this. And our emitter is an emitter that we add over here in a specific game object. We are going to get to that later. So as you can see, these appear here. And that's really smart. You only need to add them once. You can click apply and then add it to a prefab. And that way you only need to do it once. So let's go back into the code here. We need some sort of collider that we can use. So we need a private box collider, ambient collider. Now we call it ambient collider simply because it's easy to use. It's a box collider because that's the box that we need to mark up the entire area. And we also need a private vector 3. Now, vector 3s are kind of difficult to deal with if you're not really into math or know a lot about coding. So if you have any questions about how vector 3s work, let me know in the comments. So a vector 3 is basically 3 numbers, an x, y, and z coordinate. As you can see over here in Unity, its position is x, y, and z. This here is a vector 3. It's 3 numbers right after each other. That means that we can deal with 3 numbers instead of having to save them as one value. We also have some calculation needs because we want to know how big our collider is and we want to know how small it is and all these other float values that we need. So this here is all our calculation needs. This is what we need to create the calculation that we need. So these are all just going to be private because we don't need these outside of the code. Collider, size, max. And that's the max size of our main collider. Collider, size, min. Now we get to these vector 3s later and we'll explain a little bit how it all works and we'll take a look at it. We also need to define some values in which our emitter can only move within. So we need a private float just in case we need to separate the vector 3 basically. Emitter x. So this is the x coordinate of our emitter. Good. So in case we need to separate our vector 3 into 3 digits, now we have 3 ways of doing it by attaching them to this name, this variable here, emitter x, y, and z. And let's do the one final thing that is really important. We need a public bool is in area equals false. That's just what we need. The reason why we make a public bool like this is that once you go into an area and the code knows that you are in there, you will be able to see here in Unity that this will be toggled, which means that that's a nice way for you to debug. Does it actually work? Does it recognize that I'm in this area? Okay, so how does the code actually look? First, we need to establish that our ambient collider here is a box collider. And which box collider is that going to be? It is going to be the box collider that we attach to this specific object. We don't need to define it in other ways. We can just do it here by start, and it should work right out of the box. You do that by saying that the ambient collider, and this is the name that we gave it, equals, and this is how you get this kind of component. Get component like this, box collider. This means that we have now defined that our box collider here that we call ambient collider is now defined as the box collider that is attached to this object. We only need to do this in our void start because it only needs to happen once when this script is loaded. And we can define a comment here so that we always know what this is. Define that the collider we want to use is the one on this game object. There you go. In that way, it's much easier for you to decipher what is going on the next time you open this script, especially if, well, actually, I know programmers do this all the time when they make out all these comments all the time to make sure that everybody understands what is going on. And it's really, really smart if other people or yourself need to get back into this. But if you're not a programmer, I really, really encourage you strongly to use comments all the time so that you much quicker can get back into how this code works. Okay, so we need to define the location and the size of this ambient collider. So let's just say define the collider's size, scale, and set its border locations. We're going to do this by saying collider size max equals ambient collider. And that was the collider that we just defined here. Ambient collider dot transform position. Like that. This means that our collider size max, this is a vector 3. This is now equal to the transform position of this physical collider. So regardless of where you place it, this will know where we are. Okay, and we need a collider size min equals the same. Good. We also need to make sure that it's divided in two because, as you know, an area from a location, if you set it to be, let's say, 10 meters wide, then you are in the middle of that, which means that we don't need the location. We only need 5 meters on each side if it's 10 meters, or if it's 7, it's 3.5, and so on. So what we're going to do is that we are going to say collider size max plus equals transform dot local scale divided by 2. This means that collider size max plus equal means that you take the value that is already there and then you add a value to it. And in this case, we want to simply add the divided value of the scale in 2. So the scale is here. Let's say this ambient collider here is 100. It's 100 meters wide, 100 meters long, 100 meters tall. So this is the value of 50 that we get back into here. So now collider size max is equal to where it is plus 50. So that we know that regardless of where this is placed, 50 meters in either direction, we are still within the collider. Okay, so collider size min, same thing, but minus equal transform dot local scale divided by 2. This means that the minimum size of our collider is the same. So we are where we are. All right, that was the Igor ringtone again. It was my kitchen assembly guy who was coming by tomorrow. Okay, so this code is going to get a little bit hairy. So right now we have to find that our ambient collider is equal to this position and that its scale is divided by 2 so that we now know the max size of it all. So as you can see here, let's say we have our collider located here. It is located in this location, and we know that the scale is, in this case, 100, which is a nice straight up number. But if it was a different number, it would also work because we define the position and the scale, and we take the half of that, and then we define what is our collider size maximum and what is our collider size minimum. In the code, and this is where it gets a little bit hairy, if there is a problem, you are more than welcome to fire away in the comments below. Or you can simply watch the Unity video that I did, how to do this in Unity, because it works exactly the same way. So we need our listener position to be equal to our characters transform position, because we know that our character here is carrying around the listener. Even though we move the listener to a separate game object, the character itself is actually what we want to control the emitter. So listener position equals the character's transform position. So if listener position, and this is where it gets a bit hairy, listener position dot x, because it's a vector 3, we know that. If that is greater than collider size min.x and listener position.x is smaller than collider size max.x, then, and this is what we're trying to do. If our character is inside the collider, as defined here, that if our listener position's transform value is within the borders that we have set, smaller than collider size minimum and greater than collider size maximum, then we know what to do. And what we want to do in this code is that then emitter x becomes equal to listener position dot x and end the line. Okay, so we need to do this per coordinate, so x, y, and z. And that's why it gets a little bit hairy. So let's zoom out a little so that we can see the code better. So if listener position is greater than collider size minimum and smaller than collider size maximum, the position of the emitter becomes equal to the listener's position x. This is how we make sure that if we are outside of the collider, the emitter stays. So what we're going to do is that if listener position.x is smaller than collider size minimum.x, then emitter x becomes collider size minimum.x. End of line. So here we define that emitter x is equal to the coordinate of listener position x. But if we are outside of the collider, emitter x becomes equal to the minimum size of the collider. And if listener position dot x is greater than collider size max dot x, then emitter x becomes equal to collider size max dot x. End of line. And this needs to be defined for both x, y, and z. You basically just copy paste this code and you replace it with x and y's and z's. So we can do like this and say here and here. And then simply just replace this here and say y, and here, y, and y. Okay, good. So now that is defined. We have our three coordinates here that if the listener's position is greater than x, then our emitter x value becomes x. If it's smaller than x, then our emitter x becomes the size of the minimum collider size, and the same thing. So all these ifs. I'm sure that there is some coder who's going to be very cringy about this because there's so many ifs, but that's how we're dealing with it. It's a little hairy, but check out the Unity video that I did on this, and you can try and see if you can decipher how this works. It took quite a while for me to figure it out on my own. Anyway, we need to know if the player is in this area. So only if you're not in the area already, then we create a new coordinate based on these values that we have here. So if not is in area, and that is the Boolean that we defined up here, that we're going to use to define if we are in the collider or not. So if we are in area, then audio emitter dot transform dot position becomes equal to new vector 3 emitter x, comma emitter y, and emitter z. What this does is that if we are not in the area, then the audio emitter gets these values. This is the new vector 3 that's going to define the 3 transform position values of our audio emitter. And our audio emitter is this one here. And our audio emitter is this game object here that we have added a object to it here. So now we need to make sure if we are entering this collider, or if we're inside the collider, we need to make sure that these values are using the coordinate that is inside the collider and not the one that's outside, which was the one that we just defined here. So void on trigger stay. We're going to use stay and not enter here because we simply just want to know if we are staying inside the collider. We don't want to know if we entered or exited it. We need information all the time. And of course, if it's not the player, then it shouldn't do anything. So if other.tag is not equal to player, then return. So if it's not the player that's entering the collider, if it's not the player that's staying inside the collider, then we do nothing. We just return. If it is the player that is entering the collider and staying inside it, then we get to this line of code. So we can say that if the isInArea Boolean is not already true, then define and set that as isInArea equals true. In that way, we make sure that if this Boolean was false, and we now know that we are inside the area, it becomes true, so that we now know that we are inside the area. And our audio emitter .transform .position becomes equal to our listener position. This means that the emitter will, because of these coordinates that we made here, only move inside the collider. And if we are outside of the collider, it will only be allowed to be the max value of the collider size, or the minimum value of the collider size. But if we're inside it, the audio emitter follows the listener position. That is why we can walk around inside this collider and our emitter follows us. So we can write a comment here about what we just did. So if our player enters the collider and stays, check if isInArea is false and set it to true. Set the emitter's position to be the same as our listener position. There you go. So this is basically cutting it into cardboard for not only me and not only for you, but also for everyone else or yourself if you ever return to this script, that this is what this does, in case you forget, which I basically also do all the time when I get back to scripting. So that's it for that one. So we also need, if we exit this collider, we need some very specific things to do. So if we have a void on trigger exit, so if we leave this collider, then we need to set the isInArea to be false again. But that should only happen if it's, of course, the player. So if other.tag is not equal to player, then return. In that way, we avoid the script to suddenly be triggered by thousands of other objects that are moving around. And it's only if it's the player that moves into this collider. Especially with the on-trigger stay, that's not only if it enters the collider, it is if any object is staying inside the collider. So you can quite quickly imagine if there's just any kind of rigid body inside this collider, then of course that won't work. So this is why we define that it has to be the player. Okay, good. And we need to get to this line of code because if it is the player, and if we're exiting the collider, we need to make sure that isInArea becomes false. And that's really easy because that Boolean is used to check if we are inside the committer. That Boolean is used to check if we are inside the collider or not. And we set that to be true up here if we're staying inside the collider, and we set it to false if we ever leave the collider. In that way, this line of code ensures that the emitter follows the listener's position if we are staying inside the collider. But if we are outside of the collider, all these things here are still valid, which means that the vector 3 of the audio emitter's position becomes equal to the coordinates that we set here. So it cannot move in and outside of the maximum and minimum size of the collider. Good. So let's make a quick comment here saying that if we leave the collider, make sure that isInArea is no longer true. Ta-da! And that's how that works. This is basically, I wouldn't call it really hardcore code, but there's a lot of lines of code here that we are needing to decipher. And as an audio designer, it gets really hairy because you need to keep track of all these mathematical terms and other things. So keep that in mind. And if you have any problems, feel free to fire away on Patreon or the YouTube comments below, and we'll get to it. Now, what we also need to do, we need to define our audio emitter. And over here in our ambient area, you see we have the collider here. I have defined by a new game object that this is where our emitter is, because then this script here will move this emitter around. It just simply moves the game object, doesn't move any emitter object or anything like that. It just moves this game object. And that is why it's really important to do this. So over here we have an ambient area emitter script. And this is our ambient event name that we're going to fire in Wwise. You can see it over here in Wwise. We have our house, house 2, and outside ambient. And this specific one fires the outside ambience. And this is an outside ambient event that I have created. It just plays outside ambient, and it seeks within the first 10 to 90% of the file. As you can see, I've created 50% seek percentage here, and I've added a random variation between -40 and 40, so that it goes between 10 and 90. That means that it never starts at the same moment whenever you enter and exit this collider, which is smart, because then in case you have several of them, you possibly remember from the previous tutorial about how to make these fire barrels work. If these trigger at the same time, you basically get slight phasing, or if they trigger at the same time, you don't. But if they trigger within like 1 frame or 2 frames different of each other, you get nasty phasing between these two areas, and we don't want that. So in this script here, the ambient area emitter script, we have defined what's the name of the event, and we have defined if we are inside the collider or not. We register our game object as we would normally do, and we add a sphere collider here to this object. The thing is that this object follows the size of this object, so you can always just set it to some value here. If you set it to 1, it becomes equal to the size of this, which means 100, and you don't need that. So here, by 0.25, that means that our scale of this sphere collider becomes 25 meters. And that matches pretty well because I have set my ambient SFX over here to be positioned within a 25-meter radius, like this. So if we enter the collider, if anything enters the collider, and it's not the player, or we are already in the collider, or the ambient event is null, do nothing. Ambient event is null is really important because then it doesn't fire a faulty event that you don't need. And Wwise will, of course, freak out over that. AK Sound Engine post event, and then it posts the event and it spawns it on this specific game object. And of course, we now know that is in collider becomes true. While we're staying inside the collider, and this is really important because why have both an enter and a stay? The thing is that what if you start the game inside this collider? Then your on-trigger enter will not trigger because you're not entering the collider. That means that if it's not the player, same thing, return. But is in collider becomes true, and we post the exact same event here. And if we leave the collider, the same thing goes. If it's not the player, if we're not in the collider, and if our ambient event is null, then AK Sound Engine posts an event that we call the stop event, as you will see over here. And this is the one that we have here, so we need to define that, and we need to make stop events for all of these outside ambiences. And that's it. So when we move around in our editor, you will see that the collider will control how these things work. And I'll show you one of the other areas that we have where it's a little easier to see. In here in Unity, we have, this is the big one that I showed you before, but we also have one for a small house down here. So if I move around my character around this front area of it here, it is defined by covering this little collider here, which is by the size of this house. And the emitter is here. This emitter will move around with the player. And as we enter this area, it will suddenly follow us around, and when we leave, it'll stick to the walls of the collider. Check this out. So as you see, where are we? Here we are. As you can see, the player on the left side of the screen, I'm moving around outside of the collider, but the collider makes sure that the boundaries of the collider sticks to the emitter, or the emitter sticks to the boundaries. So when I enter the collider will follow me around inside the area. And then when I leave again, it sticks here. I've made a separate sound for this indoor room, which is indoor house 1. And now you can hear it's playing inside here. This is our indoor here. And as I leave, the outside ambience will come back. And that's a really smart way of opening up all these areas so that you can crossfade between them and have all these events play. That's it for this video. I really hope you enjoyed it. It was a little bit of a hairy code, but in the next video, we'll get to how we can actually crossfade between these areas, and we'll make sure that you can calculate if we are inside one area or the other, and we'll make sure that it can ignore each other so that we can actually create an ambient system that we can actually use by just doing like simple code like this. Thank you very much for watching. Don't forget to like and subscribe. Thank you for watching Cujo Sound. If you want to know more about game audio, Unity, and Wwise integrations, please like this video if you enjoyed it and hit subscribe if you want to know more. Or head over to patreon.com/Cujo Sound, where you for as little as $1 a month can help me sustain this channel and the time I take off to create all this material. I would really appreciate it. Thank you for watching and see you next time. Cujo Sound and Bjørn Jacobsen signing out.